Due to cost and processing difficulties, usually large-sized magnets are made up of many small magnets bonded with magnet adhesive. In addition, as the core component of permanent magnet motors, the fixing method of magnets is crucial in the motor assembly process. In permanent magnet motors, magnets typically require the use of adhesives to secure them to the rotor core of the motor. Considering the diverse performance requirements and working environments of motors, selecting the appropriate adhesive is particularly critical. Common materials that require bonding include ferrite magnets and neodymium magnets with different coating treatments, such as zinc plating, epoxy plating, etc. In addition, there are motor components that work with these magnets, such as galvanized steel or aluminum alloy motor casings and motor rotors. A good adhesive should have good mechanical properties and resistance to corrosion and high temperatures. Of course, we should choose the most suitable product based on specific needs. Epoxy resin and acrylic are two widely used adhesive types in the magnet industry. Excellent heat resistance, some products can be used for long periods of time at temperatures ranging from -60 degrees Celsius to 250 degrees Celsius. Its working temperature in high-temperature environments is basically the same as that of neodymium magnets, making it the preferred choice for bonding and fixing high-temperature neodymium magnets. Epoxy resin molecules contain a large amount of epoxy groups, which can react with other active functional groups such as amines and phenols to form three-dimensional polymers, forming a polymer network structure. Epoxy is difficult to break even in extreme environments, which makes it resistant to the erosion of various chemicals. This structure also makes it have good shock resistance. Epoxy resin adhesives are widely favored for their excellent electrical properties, excellent chemical stability, and high mechanical strength. Especially in high-temperature working environments such as high-power motors, it is often used as an adhesive material for high-temperature neodymium magnets. However, the curing process of epoxy glue usually takes several hours or even days, which reduces production efficiency to some extent, and the bonding effect on plastic is relatively weak. Acrylic adhesives have poor heat resistance and are generally suitable for working environments with temperatures ranging from -30 degrees Celsius to 120 degrees Celsius. The molecular structure of acrylic adhesives contains long carbon chains and ester bonds. These ester bonds are relatively susceptible to hydrolysis, especially in alkaline or acidic environments, resulting in molecular chain breakage, thereby reducing bonding strength and corrosion resistance. Acrylic adhesives are composed of long-chain acrylic polymers, which form flexible cross-linked networks during curing, effectively absorbing and dispersing external forces, making them less prone to breaking when subjected to shock or vibration. The three-dimensional network structure of epoxy resin adhesives has high rigidity and strength, but it is relatively lacking in flexibility. Therefore, when subjected to impact or vibration, the rigid structure of epoxy resin adhesives tends to generate stress concentration, leading to the formation and expansion of cracks. In addition, the glass transition temperature of acrylic adhesives is usually lower than that of epoxy resin adhesives, making them able to maintain flexibility and elasticity at lower temperatures, while epoxy resin adhesives tend to become hard and brittle at lower temperatures. Acrylic adhesives can be cured quickly, with a preliminary curing time of only 3 to 5 minutes. Acrylic adhesives have good bonding properties for plastics and metals, but are relatively poor for glass. It is mainly used in motor magnets that require high vibration resistance, but low temperature resistance. Nickel coating has strong corrosion resistance and is one of the most commonly used coatings for neodymium magnets. But its disadvantage is that it is difficult to use adhesive for bonding, which can easily cause the coating to peel off. Nickel is an inert material with high chemical stability, which makes it difficult for adhesives to form effective chemical bonds with nickel plating, affecting the bonding effect. When the surface roughness of the plating is 15 mm, it is most suitable for bonding. However, the surface of the nickel plating is too smooth and the roughness is not enough, so it is also difficult to obtain effective mechanical bonding in the surface area. In addition, nickel plating will react with water vapor. Over time, water vapor penetrates into the interior of the adhesive, resulting in a gradual decrease in the strength of the adhesive. Zinc is the most adherent of the coatings on neodymium magnets and is well suited for the use of adhesives. Zinc is a relatively active metal, ranking ahead of hydrogen in the metal activity sequence. This means that zinc atoms are more likely to react with other atoms or molecules to form stable chemical bonds. If you find the video useful or interested in our magnet products, please subscribe to our channel or contact us. See you next time.